All right. Shh. All right, Shush. I'm gonna talk about today's kinematic, and you're gonna get exact same setup in kinematic. It's pretty general. You're gonna get all different parts question. The part's gonna have 6 parts, and then it's gonna ask each individual questions. And I'm gonna talk about the relationship between physics and calculus today. And if you don't understand, you're gonna learn it very quickly. You're gonna learn basic physics today. I'm gonna teach what Green will teach in the whole quarter in 20 minutes.
Yep, no, exactly.
Okay, I'm serious.
Entire quarter.
I'm
just kinematic.
Yeah, and this I only can cover 1 dimension. I cannot cover 2 dimension, but the idea of 2 dimension is not that bad. Okay, so let's talk about kinematic. Okay, so let's start from very beginning, guys. Listen, free fall. We're gonna start with a free fall. Free fall in physics. Free fall, in physics, the gravity constant is a little bit different than calculus. It's 9.8 meter per second square negative. In calculus, is gonna be negative 32 feet per second square. That is physics. Okay, so in physics, you are gonna have. Let me make sure I'm streaming. I am streaming. Good. Okay, so in physics, it's 9.8 meter per second square. In calculus, it's gonna be negative 32 feet per second square. Everybody taking physics right now? Yeah. All right, good. So this is not something different. So for me, like I kind of interchangeable with SAT and HT because HT just talk about the height. So usually in free fall, I use the SFT or HT that just talk about position is equal to negative 9.8 or negative 4.9 t squared, and this SFT and HFT is equal to negative 16 t squared. So that's called free fall. Free fall, that means the t squared is gonna give you the t squared is gonna give you the information to tell you that the t squared is gonna tell you that how much it dropped. Okay. So I remember this movie a long time ago, but you guys are too young to see that movie. Is Journey to the Center of Earth. Have you seen that before? Yes? With a Brendan Fraser. Good. Irvy says Brendan Fraser? You know who Brendan Fraser is? You met him? He's fat now.
Yeah.
Yeah. Now, yeah, before he was like, okay. I mean, I won't say good looking, but I would say it's all right. All right. So Brendan Fraser, I'm glad that like my last period, nobody have seen his movie before. He's in the Mummy, huh? Yeah, nobody know who Brendan Fraser is. That's the guy. Okay. Put your phone away. Shh. Maddie, put your phone away. Thank you. All right. So what we're gonna do is we're gonna talk about what a free fall is. In Journey, Center of Earth, there was a thing that they travel the center of the Earth, and they have in the pitch black, they have a cliff, and they need to climb down, and the cliff height is unknown, and so question mark. And this is a Brendan Fraser. He had 400 feet of ropes, and he don't know how high the rope, how high the cliff is. So how did he measure how high the cliff is? If he knows that he has 400 feet of ropes, does he have enough? He don't want to climb. If it's 1,000 feet, you don't want to climb down 400 feet and get stuck in the middle of the cliff. So what do you do? Throw a rock. Well, he happened to have a glowing stick. He throw the glowing stick or connected like some ring or something like that, so he can see. But he throw it in, like he don't see it because it's kind of far away because it's pitch black. So he had to rely on the sound. So the sound, how long it takes, right? So how do you measure the height based on how long it takes? Well, basically using this formula here, this formula can kind of tell you in 1 second, it's going to drop 16 feet. That's not a lot, right? And then let's just say if I plug in 2, that's going to be negative 16 times 2 squared, which is what? 64 feet. Oh, that's quite a bit. See, the first, you thought it's going to be dropped 32 feet, but it's not. It's not linear. It's quadratic. So in 3 seconds, it's going to drop 9 times 16, so it'll be 144 feet. In h of 4, it's going to be negative 16 times 4 squared. That's equal to negative 256 feet. In h of 5, that's equal to negative 16 to the 5 squared. That's equal to 400. Thank you. So just show you in scale. So each square that is going to be representing 16 feet. So in 1 second, it's going to drop that much. So in 1 second. In 2 seconds, it's going to drop this much. In 3 seconds is I am going to go 9 spaces right here. This is 3 seconds. This is how fast it dropped. So each square is going to represent 16 feet. In 4 seconds, it's going to drop total of 16. So that's 9. 9 plus what equal to 16? 7?
Yeah, it's 7.
That's 5. 7 seconds. Oh, sorry, 4 seconds. Right? So that's how, see that it's growing larger. The distance is larger and larger. And last one is going to be 25. So it's going to be 9 spaces. So that is 5 seconds. So, and you in the physics books that you also the cover of the physics book usually have this picture of ball dropping with a different frame speed, different shutter speed, and you can see that ball is dropping like the same ball, but it's gonna dropping like how you doing a glowing stick dance, and you can create different shutter speed and you can connect all the glowing stick. The same thing, that ball is gonna drop in different frames, and it's gonna have those representation. Is that okay?
Are we getting separate on the side of that?
What?
Are we getting the like 15, 25, 35? Okay.
1 second, 2 second, 3 second.
So how is it getting 15, 25, 35?
No, you're just
But a second.
The 5 are essence, what you're looking at.
Oh.
It's like the 15 at the top.
Mm.
Is a
Oh,
1
okay,
second.
that makes
So in 1 second only drop 16 feet, and 2 seconds drop this. So this is in scale motion, so that you can see how fast it is falling. Now, ideally, usually you drop everything, there is a terminal speed. So because there is air resistance in realistic world, it's gonna have a terminal speed. That's why Mythbuster, I don't know, there's a long time ago, there's a show called Mythbuster, that they always claim that if you drop a penny on the Twin Tower, well, Twin Tower no longer exists, but before Twin Tower exists, before Twin Tower, they used to have like something outside, says don't throw stuff outside. They have a glass. Yeah, they have a glass shutter outside, and they say don't throw anything. But supposedly, if it go with this speed, that penny will go through somebody's skull. But the thing is, it's not true. Mythbuster says it's not true. Why it's not true? Because the penny will be flattened and it will become it will have a lot of air resistance. So it have a final speed. It has a terminal speed of, I don't know how fast it is. So, huh?
11 miles per hour.
Is it?
I don't know.
I don't know. Okay, good job. So yeah. Okay, so is that okay? Free fall. Free fall is a negative 16t squared. Now in physics, we're going to talk about projectiles. Projectile is different. It's throwing something up, like you're shooting a basketball, hit a golf ball.
30 to 50 miles.
30 what?
30 to 50
Miles per hour. It has a terminal
But,
speed.
but it only has like about a force of like what?
50 miles. I just had 30 or 40.
Okay, projectile. What I mean by projectile? The projectile is gonna have. Projectile is gonna have. Okay, so projectile is gonna have something throw up. So it's gonna be S of t. Now I use S of t or H of t. Doesn't matter, they all position changes. So it's always gonna be a free fall. So this is a free fall part. Free fall part. So 16t squared. Now in projectile, you also have this part is v0t. Why is v0t? Because you might throw something up. So v0 is going to be initial velocity. That's going to affect how your projectile is going to go and affect your displacement. And also, you might hit a golf ball on top of a mountain or on the ground. It's going to be different because it's going to be different how long they hit like to the sea level. So if you hit on top of a building, it's going to take a little bit longer because you have to travel past the building, right? So you have to think about the initial velocity. So this is how fast you throw up. So there's initial velocity here. So I'm going to say t is equal to time. V0 is called initial velocity. S0 is called initial positions. Okay, initial position. Now, what is S of t? S of t is a positions at giving time. Now, in physics, you might get some other equation. In physics, you might get S of t is equal to negative 4.9 t squared or half g plus v0t plus s0. It's similar things that you get in physics, or x0 they call it. So that's that. Now, you can take a derivative of the position function. What's interesting is if you take a derivative of the position function equal to v of t, which is s prime of t equal to v of t is equal to negative 32t plus v0. Because derivative of t squared is going to be 2t. 2 times negative 32 times 16 is going to be negative 32. Take a derivative of t, it's just going to become 1. So you got v0. So what does vt is? Vt is called instantaneous velocity. I have no idea how to spell instantaneous. E-N-E-O-U-S.
No. A-N.
That looks right to me.
Wait, actually you cooked. I think it's only one letter wrong.
Huh?
Only one letter wrong, you cooked.
I don't think so.
I have no idea. I don't really care. But instantaneous.
Yeah, you got it right.
So I had the original right?
No. The E was wrong, but you got only one letter wrong.
Okay.
Pretty good.
Not bad. For a fob like me.
You're not even Bob, you went to high school at DP. You're the Bob. Everybody's so damn.
Like people were like, you went to DP. Well, Mr. J, did you go to DP when it was still good, or?
I went to DP when it's still good.
Okay.
Yeah, and he still doesn't know English.
You know what? Okay, instantaneous velocity is v of t. Now you can actually take a derivative of instantaneous velocity. So it's s double prime of t. If you take two derivative on position function or one derivative on velocity function, it's going to give me a of t, which is called acceleration. I see you, Tony. Huh? That's not. That's not a good sign. You're gonna fail this class if you continue like this. Okay, we already talked half of the class already. Okay, so in what?
Is that v prime of t equals a of t?
Yeah.
Okay.
So if you take a derivative of velocity function, it's gonna give you a of t. Now, what's a of t here? If you a of t in here is always gonna be -32, which is that's exactly the gravitation constant. Acceleration is same as gravitation constant. If you take a derivative of 4.9 t squared, if you take two derivatives, it's gonna be 9.8 meter per second square. Always like that. So it's gonna be feet per second square, or it's -9.8. Okay, so that's acceleration. I'm gonna talk about one more thing. One more thing is how do you find average velocity? Everybody got wrong on this test, so I don't want you to get it wrong. Is average velocity is changing of position over changing of time, which is s of b minus s of a over b minus a. That means I'm gonna plug in two different time on my precision function. I'm gonna get two different position. I subtract two position over the time. It's called average velocity. Average velocity is always different than instantaneous velocity in most cases. But most of people though is plug in the velocity equation. No, you do not plug in into velocity equation. That's how you get the wrong answer. Okay, do not plug in the velocity. It's not v of b minus v of a over v minus a. Average velocity usually like this. Okay, questions?
You mean like you have to plug in the 32 into the SB?
Yeah, plug in the position functions. Okay, so here's a question for you. A ball or a potato launcher, whatever, is throwing straight upward. Throwing straight upwards at the velocity at 96 feet per second on top of 180 feet buildings. And you say, okay, can you tell me what the position function is? So position functions in the situations. So what's the position function? 96 feet per second on top of 180 feet building.
Is that the -16 t squared?
Yep. S of t equal to, remember, this is the free fall part. Everything falls. Everything you throw up is always fall back down. That's how you stay grounded. Plus what?
96.
Plus 96t, which is that's your initial velocity. because now you had to take account not only in free fall, you had to take account you throw it upwards. And also take into account into your initial position. What if I throw it on top of 1,000 feet mountain, 180 feet building? If I hit a golf ball at 180 feet building, it's gonna fall different time than I hit it from the ground. Does that make sense?
But in a time, it's like below 180. Wouldn't it be 0 because you started at 180? You throw it straight up on the building, it's gonna land on the building.
Yeah, but you don't want to land on the building. It's straight up, but we're gonna like, a little bit off the building so it can hit on the ground. So it's not like it's very straight up, but it's gonna.
Is it going off the building?
Yeah, it's
Yeah.
arcing.
Okay.
Okay, so is that okay?
Yeah.
Can you find the velocity equation for this one? How do I find the velocity? Not any type of velocity, instantaneous. Take a derivative. What's the derivative of this function? Negative 32 t plus 96. We already finished 2 parts of the questions. This is easy 2 parts, right? Okay. So now B, the question I'm gonna say is find the time when the ball reach maximum height. Okay, find the time when the ball reach maximum height. How do I do that? I don't provide a formula for that, but how do you find the time when the ball reach maximum height? Corbin?
Would you set the velocity equation equal to 0?
Why?
Because when the velocity is 0, that means that it's reached maximum height and it's not come back down.
All right. Pay attention to the marker I throw at Corbin.
Oh, yes. No, free cap.
Corbin, pay attention. The marker is coming your way. Okay. So if somebody were to record this in slow motions, right?
I got it. Don't.
I need a slow motion. I need a slow-mo.
Okay.
I need a slow-mo. So you have to, before I throw it, I'm going to give you 1 second or 2 second warning because that 2 second you're going to click on, but slow motion is not going to kick in after 1 second. So is that okay?
I don't know why it does that.
Okay, so 3, 2, 1, plus play, and I'm going to throw. Okay,
I think I could.
did you record the whole thing?
Yes.
Okay.
I can't believe I missed it.
You look just like just forward.
All right, come again. Everybody come look at the camera here. Okay. So this thing is going upwards. So you see when it, as soon as they left my finger. Oh, yeah, throwing motion. It's like a follow throw. Yeah, it's like switch right there.
Step 30 right
Okay, so step 30 right here. Okay, so as soon as my marker left my hand, it has some type of initial velocity. But the gravity is going to hold us to the ground. So it has upward motion. Velocity has upward motion. It's still going up, right? It's still going up. And sometimes it's not going to go up anymore. That's when the velocity is equal to 0. See, almost right here. Right here. Right? Now it's going to come back down. So somewhere around this point here, there's no upward motion anymore. And then it's going to start falling back down to right here. But somewhere around right here is my maximum height. So my velocity is equal to 0. Does that make sense?
Yeah.
You think I got it?
Yeah.
Okay, so this throw up, come back down. Now also this is when they hit the floor, and so that's what happened. So anyway, thank you.
Don't die.
And I can't.
Okay, so what do? We set, according to Corbin, set the derivative equal to 0. Set the velocity equal to 0. So v of t equal to 0, and that is going to be negative 32t plus 96 equal to 0. T is equal to 3. So it takes 3 seconds to reach the maximum height on top of 180 feet buildings. Some people says it takes 6 seconds to land on the ground. Well, imagine that you throw that ball with a little bit arc, because if you throw straight up, it's gonna head back to the building. Yeah. So Aiden was right about if I'm going straight up. But if I have some type of arc, I'm gonna like on the edge of the building. If I'm throwing up, it's gonna take longer to fall on the ground, because at first it's gonna reach the building and gonna reach past the building, then on the ground on the end. Does that make sense? So you have to understand that. So let's find the ball when they reach the maximum height. Is it possible to find the maximum height or not? Can you find the maximum height? How do I do that? Plug in t into the position function. So it's s of 3. And s of 3 is going to be negative 6, 3 squared plus 96 times 3 plus 180. So whatever that is, I have no idea. I'm negative 16 times 9 plus 288 plus 180. I think that's going to be 324 feet. So maximum height is going to be 324 feet because I plug in 3 into the original function, not a position, not a velocity function. Position function, not a velocity function. D. Is it possible to find instantaneous velocity? At t equal to 2. So is it possible, can I find instantaneous velocity at t equal to 2?
Yeah. Just plug a 2 into the negative 32t.
Plug in 2. Negative 32 t plus v0, which is 96. So can I just plug in 2? That's equal to 32 feet per second. Now you also have to include in units because you can plug in that. So instantaneous velocity are a little bit different than average velocity. Do you guys know the difference between average velocity? So how do I find the average velocity? Now, if I ever ask you average velocity, I'm going to give you 2 separate time intervals. T equal to 0 and t equal to 3. So what's the difference between average velocity and instantaneous? Well, how do you find the average velocity here?
J hit speed. J hit speed. Well, I know that, didn't you need to throw on this video. I don't know. Yeah.
So how do I find the average velocity between t equal to 0 and t equal to 3? You do the precision on both, not velocity. Because if you plug in velocity, it's not average velocity, it's actually average acceleration. Because the change in v over change of t is average acceleration. You don't want to plug in the velocity equation, you want to plug in the precision equation. It's s of 3 minus s of 0 over 3 minus 0, which is 324, because we know from earlier, minus, well, s of 0 is 180 over 3. So that's roughly about 48 feet per second. So remember, your instantaneous at t equal to 2 is 32 feet per second. But find the average velocity, usually they give you 2 time intervals, 0 and 3. And they say, hey, can you find out the time? Can you find the average velocity? It's a changing position over changing time. So just plug in 2 different positions into original function and divide it by times. Is that okay?
What's a
180 is the initial height
Oh.
because t equal to 0.
So it doesn't matter.
On
Like,
that one weeks.
It's always gonna be 48. Cause like,
How
what
would
if
you
you
want
put
to
a
work
zero
half
here,
like
and
9
put
weeks?
three here?
20.
Yeah, it's because it's gonna be 0 divided by 0 subtract 3. So.
Is it just half of the initial velocity?
Huh?
Is it just half of the initial velocity, or is that
It's just a coincidence because I can say t equal to 4, then that'd be different. Okay, shh. Now, I want you to find the time when the ball hit the ground. Okay, that's the first part, and F, I'm gonna find the velocity when the ball hit the ground. Okay, so how do you find the time when the ball hit the ground?
You put, instead of 180, you put 0.
No.
What did he say?
I'm saying find the time when the ball reached the ground.
The acceleration equation equal to 0?
Nope.
No?
Acceleration never equal to 0, otherwise we'll be floating right now. It will be like on the air like this.
Well, no, that means we're either just moving or we're just frozen in space.
So find the velocity when the ball hit the ground. No, find the time when the ball hit the ground. How do you find the time when the ball hit?
It would be negative 180.
we set the time.
Set position equal to 0. Good job.
It's a,
S and T represent the height, right? The height equal to 0. Does that make sense? If it's 0 equal to negative 16t squared plus 96t plus 180, guess what? I probably need some factoring skill here. I don't like the negative sign on very beginning, so I'm gonna factor out a negative sign. But 1696 and 180, what can I factor out? Because you have no calculator and you don't want to use quadratic formula.
8?
I don't think you can factor out 8. 4? So what happened if you factor out 4? You're gonna have 4 plus, I think, negative 24, right? And minus what? 45? I don't know.
Yeah.
So I am gonna use my beautiful box method because this number gets kind of spicy. This is t here. I'm gonna do 2t and 2t. Maybe 15 times 3. Hopefully that work. 36. Oh, that worked. This one's negative. So it'll be 2t minus 15 times 2t plus 3 equal to 0. T equal to 15 over 2. T equal to negative 3 over 2. You cannot get negative time. T equal to 15 over 2 is the time. And you say, yes, I find the time when I hit the ground. Can you find the velocity when I hit the ground? Do not tell me 0. I mean, technically, like 1 second after that is going to be 0.
Can you zoom in on that?
But when they hit the ground, it's to have a speed on it. So how do you find the velocity when they hit the ground? How do you find velocity when they hit the ground? Yes.
You just plug them 15 over 2 into the velocity equation.
Yep. So plug in that. So it'll be negative 32 times 7.5 plus 96, I think. Is 96? Yeah. Can somebody work it out that? I don't know what it is. Actually, I can do it. Times 15 over 2. This is going to be 16. 30 times 8. So it'll be negative 240 plus 96. So that's equal to, what is it?
Negative 144.
Negative 144 feet per second. And that's pretty fast. That's enough to break your skull. But definitely break your skull, for sure.
Fine.
Case built different. So we find all the information. Now sometimes, some of you guys says, does that make sense or no?
If you go back to the
Does that make sense? I teach you
like the connectors
in 20 minutes more than more than we're teaching the whole 9 weeks. No, I don't blame him. I don't blame him.
He could have teaching the same thing.
Just got rid of
Huh?
the 2.
He can't
It's 15 over 2. You got rid of the 2. So you made it 60. And it's half of 32.
Yeah.
Okay.
It's just funny. This number.
Okay.
It's 16 over 1. 16 over 1 times 15 over 1 times 1/2. You just put the 1/2 of the 16.
So there we go. That's all the kinematic you need to know. I will give you almost exact same questions. Just different numbers. And then you gotta know how to factor. You know how to do what, when, how, and stuff like that. So I'm gonna talk about this part. Some people says negative b over 2a. Do you guys remember something called negative b over 2a? So I'm going to show you where the negative b over 2a come from. Imagine you have at squared plus bt plus c, right? Imagine you have that. That's your s of t, right? Imagine I take a derivative. That is going to give you what? 2at plus b. Do you remember that? So now I take a derivative. Set a equal to 0. 2at plus b. Move the b to the other side. Negative b equal to 2at. Solve for t. Negative b over 2a. But I don't want to use this way. I want to show you. In algebra 2, we use negative b over 2a to find the maximum height. But in calculus, we take a derivative, set it equal to 0. We find out when velocity equal to 0. That's a better way. But this is why they use in algebra 2 negative b over 2a, which is the first part of quadratic formula. Negative b over 2a plus minus square root of b squared minus 4ac. So there you go. Those all the physics you need to know. For me, unfortunately, I cannot cover two-dimensional, but two-dimensional basically just involves sine and cosine. Yep.
Yeah, I mean,
It's common sense. I think
I
it's
know.
part of it.
He's going green wall. He sucks at teaching. I hate him.
He was forced to be in that position. So he's supposed to teach AP Chem.
Yeah.
So I don't blame him. It's doing okay. He tried his best.
Sometimes when he gives homework and doesn't tell us, and then gets mad at us for not seeing that there's homework.
All right. So does that make sense for everybody?